Hi, this is Emily Romero, the creator of the Brain on the Web open educational resource. Thank you for utilizing Brain on the Web. It is meant to give learners an understanding of the three-dimensional human brain from a tactile perspective. Research has shown that the more ways in which one engages with a topic, the better one's understanding will be. Thus, I find it beneficial for all users to get a sense of what the brain would look like from this three-dimensional perspective. In what you're about to see, I'm going to use modeling clay to recreate some of the parts of the human brain. I hope that you enjoy this segment, and I hope that you find it informative and interesting. Thank you.
This is the second video in the Brain on the Web series, and in this one we are going to be modeling what the lobes of the cortex look like relative to each other. This is the sequel to the previous video in which I demonstrated how to model the subcortical structures of the brain. If you have not seen the subcortical video, please go back and rewatch that first, as I think the context of the subcortical structures will make the cortex a lot easier for you to learn about. Once again, the purpose of today's demonstration is to show you that you can make a hands-on tactile model of your brain to learn the parts of the brain without needing to go out and purchase expensive models or without needing expensive tools to do it. What you're going to need is you're going to need a scoring tool. I'll put that right on the cutting board here to show you. And you're also going to need 8 gumball or ping pong ball sized pieces of clay. These should ideally be 4 different colors. I will be representing the frontal lobes in purple, the parietal lobes in blue, the temporal lobes in red, and the occipital lobes in yellow. Start out with 8 balls of clay that look like this and are about the size of a gumball or ping pong ball. And what we're going to do is we are going to taper one end of each of those spheres, and we're going to square off the other end. I'm just pinching one end to taper it. I'm flattening the tapered end a little bit, and I'm making a polygon shape with the back end. It's not a perfect square. It's certainly in the rectangle family. But it looks sort of square-ish. And this, I'm going to go put it with its twin, with its other frontal lobe. Each of these now represents one of the 8 lobes that that most people have. We have 2 hemispheres to the cerebral cortex, the right hemisphere and the left hemisphere. And each of the hemispheres has a representative of each lobe. In other words, you have a left and right frontal, a left and right parietal, a left and right temporal, and a left and right occipital lobe, unless, of course, you have had to have one of those removed for medical reasons. Let's go ahead and begin with our purple frontal lobes. The tapered end represents the part or the side of your brain where your forehead is. So my forehead corresponds to the tapered end of these frontal lobes. If you were to imagine yourself becoming very, very, very small and crawling through your own skull. Let's see, you crawl up through your nose, up here into your forehead. This is what you're going to encounter first, is these frontal lobes. Now these 2 frontal lobes should do a nice job sticking together on their own because of the kind of polymer clay we're using. It's pretty reliable for that. However, to play it completely safe, I'm going to take the pointy end of the scoring tool. That's the pencil-like end instead of the knife-like end. And I'm going to score the inside of each one. I'm just going to make a couple of hatch marks that go diagonally from each other or perpendicularly to each other. Almost in the shape of an X or a traditional Latin cross, but it does not need to be that exact. No one's going to see these marks. And these hatch marks will simply help these two frontal lobes stick together. Oh yeah, there we go. And you can see that the frontal lobes are now together as one unit, but you can also see this little groove in between them. That's where the hemispheres separate, and this is called the corpus callosum. It's a fibrous little network that allows the hemispheres to communicate, and also shows that they are, in fact, separate. Sort of like if you have two twins, they might be right next to each other, they might be doing activities together, but they are, in fact, separate people. They don't share a body. Next, before we attach the other lobes to the frontal lobes, I'll explain a little bit about what the frontal lobes are for. The frontal lobes are in charge. They are your executive functioning center, and they help with decision making and the things that we think of when we think of the brain's job. Think of them as sort of the president of your brain. They rule, they're royal. That's why we have these frontal lobes in purple. The next lobes that we're going to connect to the frontal lobes will be the parietal lobes. And the parietal lobes are responsible, two of their big functions are tactician, using the sense of touch, and sensory integration, integrating the information that you receive from your senses of sight, hearing, touch, taste, and smell together to form a coherent whole. For example, you might hear crackle, crackle, crackle. You might smell smoke, and you might see red and orange. What is that? That's a fire, according to your parietal lobe. So in this case, again, just as we did with the frontal lobes, we'll take the pencil-like end of the scoring tool and score the insides of the parietal lobes, making hatch marks that resemble an X or Latin cross. And I'll do the same thing with this one. Boop, boop. And these are going to go together. Boom. Our parietal lobes are shown in blue because they're a bit like the ocean where everything comes together. The ocean has all kinds of sea life, so that's a good mnemonic device. And we're going to attach the parietal lobes behind and at the top of the frontal lobes. Actually, I'm going to do some scoring on the front of the parietal and the back of the frontal lobes so that the lobes attach to each other more easily. Notice that I'm scoring the back of the frontal lobes, but I'm scoring the front of the blue parietal lobes because they connect back to front. And you'll also notice that the frontal lobe does not go directly in front of the parietal lobe. The frontal lobe is in front of and a little bit below. The parietal lobe connects to the top part of the frontal lobe, and we'll see why in a second. The next lobes that we are going to work with will be our temporal lobes. The temporal lobe has the hippocampus, which is responsible for memory. And the other big function of the temporal lobe that I want y'all to know right now is auditory processing. My voice coming into your ear is being processed by your temporal lobes. Your left temporal lobe is processing what comes in your left ear, and your right temporal lobe is processing what comes in your right ear. I'm going to actually go ahead and do these a little bit differently. The temporal lobes are going to attach to the back and bottom of the frontal lobes. So they're actually going to attach most closely to the parietal lobe, with just a little bit of the temporal lobe touching the frontal lobe, if that makes sense. And this will be visible and tactily accessible as well. I'm currently fusing the temporal lobe to the bottom of the parietal lobe. That is how it appears to me on most diagrams. And I have scored this lobe. The left one is done. I'm now going to go ahead and do the same thing with the right one. Fuse them together. The parietal lobes, as you can see, sit directly above the temporal lobes. Think of the parietal lobe as the top, the temporal lobe as the bottom, the frontal lobes as what else? The front, and the back will be the occipital lobes. The occipital lobes are primarily responsible for visual processing, and I'm going to score them just as I have the others. So they're going behind parietal and temporal. As you can see, there's our front, there's our middle, and the occipital lobes will be at the back. There's the right one going on. And we'll see the left occipital, which is yellow to represent sun and light, also take its place. Okay, I think we've got it. I'll just go ahead and show you everything once more. On the very right, our frontal lobes are represented in purple because they rule. They are in charge. Our parietal lobes are in blue. Parietal lobes are where all the senses come together. They're blue like the ocean, where all the sea life comes together. Our temporal lobes are in red because when we hear things, they can startle us pretty intensely. So the intense stuff gets processed through these red temporal lobes. And finally, representing sun as a metaphor for light, we have our visual processor occipital lobes in yellow. Now there's going to be one more piece that I demonstrate to this. These are simply the lobes themselves, but the lobes are covered in the gray matter of your neurons. Don't worry, I'll talk more about what the gray matter technically is in the written portion, but I'm going to show you how gray matter covers the lobes. We have white clay to represent the gray matter so that it contrasts with the clay for our lobes. And I basically am going to wrap the clay back and forth over the lobes. I'm curling it the way spaghetti would be curled, or the way that you would think of drawing the shape of curly hair. They are everywhere. They are all throughout the cortex. There's no place where they don't reach. So I'm trying to approximate that as much as I possibly can on this demonstrative model. But we now have a cortex. The lobes we demonstrated today were the frontal lobes for executive functioning in purple, the parietal lobes for tactician and sensory integration in blue, the temporal lobes for auditory processing in red, and the occipital lobes for visual processing in yellow. I hope that you have enjoyed this demonstration of mapping both the subcortical structures and the cortex. If you have any questions for me, I am happy to receive them. Please email me at emily.romero@unco.edu. That's emily.romero@unco.edu. If you prefer a phonetic spelling, that is Echo, Mike, India, Lima, Yankee, Romeo, Oscar, Mike, Echo, Romeo, Oscar, at Uniform, November, Charlie, Oscar, dot Echo Delta Uniform. Thank you very much for your viewership, and I look forward to any comments, questions, or suggestions that I might receive from you in the future. Happy learning.